Hello everyone, this is the third video in chapter 6 of geometry. Our third section, we're going to talk about proofs of parallelograms. In the second section, we talked about the different qualities that parallelograms have. So now we're going to go kind of in a converse type situation and say, okay, how much do I need to know in order to know if this shape is a parallelogram? Since opposite sides are parallel, opposite sides are congruent, consecutive angles are supplementary, opposite angles are congruent, diagonals bisect each other. How much of that information do I need to know in order to say, yes, this is a parallelogram? So that's what we're going to talk about today. Some of it's really obvious and others not so much. So think about it carefully and take notes, and then you'll just be fine. The first way that we can show a quadrilateral is a parallelogram is by comparing the lengths of the sides. If both pairs of opposite sides are congruent, then it's a parallelogram. It has to be both pairs, not just one, and it has to be opposite sides. For instance, if I had consecutive sides that were congruent, it would be a kite. So watch out for that. Make sure both pairs, if both pairs of opposite sides are the exact same length, then you know it's a parallelogram. You don't need to know anything else about it. That would be enough. You can show a quadrilateral is a parallelogram with just one pair of opposite sides if that pair is not only congruent but also parallel. So if I have a pair of opposite sides in a quadrilateral, they're the exact same length and they're parallel, then automatically the figure has to be a parallelogram. I don't need to know anything about the angles or anything about the other opposite sides. That one side is enough, but it has to be both congruent and parallel. Okay, let's look at a way we can tell by looking at angles. Just not even know anything about the sides at all, just the angles. If I have a quadrilateral and both pairs of opposite angles are congruent, then that is enough to say it is a parallelogram. But you need both pairs and they need to be opposite. So opposite angles, both opposite angles are congruent, that will be enough to show it's a parallelogram. If I have a quadrilateral and its diagonals bisect each other, so this point right here is the midpoint between these two angles, and it's also the midpoint between these two angles. Both diagonals are completely bisected by each other, then by definition, that figure would have to be a parallelogram. So that's one way to show it, just by looking at the diagonals. So those are the different ways to know if a quadrilateral is a parallelogram. Make sure those are in your notes. Now we're going to look at several quadrilaterals and try to figure out, is this a parallelogram or not, and how can we tell? Okay, here I have a quadrilateral. I have one pair of opposite sides as congruent. That's not enough. And I have these two angles. This one's 72 and this one's 108. Is this enough information to say that this is a parallelogram? So to think about it, I don't have both opposite sides are congruent, so I might think no. But remember, if I have one side, it's enough if they're both congruent and parallel. So let's look at the relationship between these two angles. This is 72, this is 108. Those two are supplementary, because 72 plus 108 is 180. That means these two lines are same side interior. These must be parallel, cut by this transversal. So now that we know, based on the angle measures, that those two sides are parallel, then that's enough. I have one pair that's both congruent and parallel. So yes, this is a parallelogram. Next figure. Is this enough information to show that this is a quadrilateral? I have these angles, they are congruent and they're supplementary. Is that enough to show that this is a parallelogram? One pair of consecutive congruent supplementary consecutive angles? And the answer is no. I don't have opposite angles that are congruent. I can't show that two lines, I can show these two lines are parallel, but I can't show that this is a parallelogram, even though it looks like it. And let me show you what I mean. It says nothing about this side. This side could look like that, and this could still be true. Do you see what I mean? So really, all this shows you is a trapezoid, not a parallelogram. I could get a problem like this, which would say find the value of each variable to show that this would be a parallelogram. These are diagonals, so in order for this to be a parallelogram, these diagonals would have to bisect each other. So for this to be a parallelogram, 5a would have to equal 20, and 6b plus 2 would have to equal 7b minus 4. So you set up those equations, solve for A, solve for B, and you've got your answer. So knowing the characteristics of a parallelogram are important in being able to solve a problem like this. So that's how you would solve. A would have to be 4, and B would have to be 6. Here's another problem of the exact same type. What would the X and the Y have to be for this to be a parallelogram? For this to be a parallelogram, both pairs of opposite sides would have to be congruent. So you would have to say that y equals x plus 11, and that y plus 14 equals 2x. And now those are a little trickier because we have two equations with two variables, and we have to put them together because I've got x and y involved in both of them. So let me walk through that just to help you with the algebra in that. So first I wrote my equations saying that opposite sides would be equal to each other. Y would equal x plus 11, and 2x would equal y plus 14. And since this equation is already solved for y, the easiest method, I think, would be substitution. Go ahead and put x plus 11 in place of y in the other equation, and then you'll be able to solve. So in place of y, I put x plus 11. Now I know that 2x is equal to x plus 25. That means x must be 25. And now that I know that x is 25, I can plug that into this equation here, make x 25, and that means 25 plus 11 is y, which would be 36. And I have my answers. So that's an example of the type of problem you will have to solve knowing how to show that a quadrilateral is a parallelogram. Here's an interesting addendum kind of to this section. I have two parallelograms. I know they're parallelograms already. This is parallelogram ABCD. This is parallelogram PQRS. My question to you is, can I prove that they are congruent parallelograms? That this parallelogram is congruent to that parallelogram. And there is a theorem that says two polygons are congruent if they can be divided into congruent corresponding triangles. So notice AB is congruent to PQ, so I have those sides, and AD is congruent to PS, so I have got those sides, and I also have angle A and angle P are congruent. That's given in the diagram. So what you can do to show or to prove that these two polygons or parallelograms are congruent is go ahead and divide them into triangles. So I'm going to draw a diagonal in each one. So I've drawn a diagonal into each one of these figures, and now I'm looking at triangle ABD and triangle PQS, and I can say those two triangles are congruent by side angle side, which means my diagonals are also congruent to each other. And since I know they're parallelograms, then the opposite sides are also congruent, so I've got two corresponding congruent triangles, and that's the method that you would use to show that these two polygons or parallelograms are congruent to each other. That's laid out step by step in the book if you want to see the step by step, but that's the approach, overall approach you would use to show that these two parallelograms are congruent to each other. Is this enough information to show that this is a parallelogram? Look it over, think about it, pause if you need to, and then I'll tell you the answer. The answer is no. All this does is tell you that these two sides are parallel because these are supplementary. That's it. I need to know that they're also congruent, so I don't have enough information. Okay, what about with this diagram? Do I have enough information to show that this is a parallelogram? Now I'm dealing with diagonals. Notice these two halves are congruent. These two halves are congruent. Both my diagonals were cut exactly in half, which means they bisected each other. In this case, yes, this is a parallelogram because the diagonals bisected each other. Take a look at this one. Think about it. Is this a parallelogram? Both pairs of opposite angles are congruent. Yes, it's a parallelogram. What about now? Is it a parallelogram now? I have only one pair of sides. They are marked the same length, so they're congruent. Oh, and those arrows mean they're parallel. So I have one pair of opposite sides that are both congruent and parallel. Yes, it's a parallelogram. So hopefully this will get you well on your way to showing if a quadrilateral is a parallelogram or not. That's it for this section. I will see you guys next time.